In this presentation, we are going to learn about another combinational logic circuit, which is decoders. And basically, decoders are very useful in computer system architecture because they are used to decode information from one format to the another. So let me just first define what exactly a decoder is. So here I have written the definition of a decoder. So basically a decoder is a combinational logic circuit. So you will have to focus on this very first point. So decoder is a combinational logic circuit, and we have already covered combinational logic circuits before. So decoder is a special one because it converts binary information from encoded inputs to maximum of 2 raised to the power n unique outputs. So basically, if I will just represent this definition in form of a diagram, you can see that this is the diagram I have drawn here. So let's suppose this box represents a combinational logic circuit. Then this means that if I will provide n inputs to this combinational circuits, it is going to give me 2 raised to the power n unique outputs. And these are basically all the combinations that are represented, and all of these combinations are unique. So let's discuss why 2 raised to the power n outputs are there. How come this 2 raised to the power n relation comes into play in this decoder diagram? So let's suppose I have 2 bits of information. So focus on this line. So I have 2 bits of information, and we know that 2 bits of information is an information that can contain 2 bits, and these 2 bits can be either 0 or 1. So the information we are going to represent in the binary format. So you can see in the definition it is used to convert binary information. So we are going to provide 2, so n is 2 in this case, n equals to 2. So 2 bits of information means that we can get all of these combinations. So let me just highlight these combinations. These are the 4 combinations that we can get if we have 2 bits of information. So you can see that it will be 0 0, 0 1, 1 0, and 1 1. Similarly, if I have 3 bits of information, I can get all of these 8 unique outputs. So you can see that there are 8 unique outputs that you can construct if you have 3 bits of information. So at this point, we have realized that actually there is a relation between the input and the output. You can see that if inputs is 3, then the outputs is 2 raised to the power 3, which gives us 8. So we know that each of these combination represents something. So if I will just write here 2 raised to the power 0 and 2 raised to the power 1 here, I know that 0 0, if we want to convert this particular combination or this particular information into the decimal format, what I will just do is I will just add the positions where we are getting 1, and since there are no 1, the output will be 0. So if I want to convert this combination into the decimal format, what I can just do is I will add 2 raised to the power 0 plus 2 raised to the power 1, which will give me 3. So here I have written all the information, all the outputs that this decoder can represent. So basically it is a combinational circuit, and if you give 2 bits of information to it, it is going to give you 2 raised to the power n, and it can even be less than 2 raised to the power n, right? So this is the formal relation that I have drawn here. So a decoder can have n inputs and less than equal to 2 raised to the power n outputs. So let's move on to this to the combinational logic circuit and the truth table for the decoders, where we will be able to understand how decoders actually convert this information, this 2 bits encoded inputs, how they will point to a particular combination out of these outputs. So if I give a 3-bit information to a decoder, let's say I give 110 to a decoder, it is going to it is going to make this value as 1, and rest of others and all the other combinations will be assigned as 0. And this is how it is used to convert binary information from encoded, where n is equals to 3 in this case, so from 3 coded inputs to a maximum of 2 raised to the power n, which is 2 raised to the power 3, which is 8 unique outputs. So such a type of decoder is known as a 3 to 8 line decoders. And in this tutorial we are going to study about this specific decoder, which is 3 to 8 line decoder. 3 means encoded inputs and 8 means 2 raised to the power n unique outputs. So let's take a look at the characteristic table or the truth table for the 3 to 8 line decoders, and this is the circuit diagram of a 3 to 8 line decoder. So this is the circuit diagram. It looks a little bit it looks a lot complex, but when I will just teach you, when I will just show you how this circuit works, it will become more clearer to you and you will draw that with ease, right? So let's take a look at the 3 to 8 line decoder. So if you have information, I have written all the possible outputs here. You can see A0 represents the first bit of this information, A1 represents the second bit, and A2 represents the third bit. So here I have written all the combinations. You can, if you focus on only these parts, you can see that I have written all the possible combinations that you can construct from a 3-bit of, or you can say 3 coded inputs. So in the last part you can see if there are no inputs given to a decoder, all the values of the outputs, all the unique outputs will be equal to 0. So in that case we have a signal which we call enable signal. So if the value of enable signal is 0, then the decoder is in the inactive state, right? So you can even see that here in the circuit diagram I have drawn an enable signal and I have provided it to all of the outputs. So if this signal is 0, it will make all the outputs as 0, and if it is 1, then it will make the decoder active. So we are going to see the circuit diagram a later bit. First let's discuss about this truth table. So you can see that if we pick up any particular combination, so let's pick up this one, you can see the information given to us is 0 1 0. So if we want to convert it into its decimal format, we know that we will get something like this. So it will give us the value. You can see that 2 raised to the power is 0, so it will be 0 plus 2 raised to the power 1 plus again this is 0, so this will be 0, so it will give us 2. So you can see that if I take this case, this one, if I focus on only this case, it will mark all the outputs, all the 8 outputs as 0 except the output which represents the D2 output, and this D2 output means that the decimal format will be 2. So this is the basic working behind of a decoder, which you can see from this truth table, and you can see how it is actually decoding the binary information and pointing it to a particular output or a particular combination. So D2 basically means the second combination, and we are starting from 0 because we can also get a 0 as a decimal in the decimal format. So if we take an example of 0 0 0, we can also get a decimal format of 0. That's why we are starting it from 0. So this is a truth table for the 3 to 8 line decoders, and we have seen how in each case it is pointing to a particular output or a particular combination, and this is how it decodes binary information into of n inputs into a maximum of 2 raised to the power n. You can see that these are 8 outputs, right? So how does this decoder does that? We want to know the working behind of this decoder. So here is the circuit diagram of a decoder, and here you can see that I have given 3 inputs. I have generated 3 inputs to this decoder, A0, A1, A2, and here you can see that I've used this AND gate. I'm going to write AND here. So this is basically AND gate, and we know about AND gates when we studied about logic circuits. So you can see that there are 8 AND gates because we are studying a 3 to 8 line decoder. Since we are studying 3 to 8 line decoder, these are the 8 outputs, and at each we have just written here, drawn here AND gates. So what you will have to do is you will have to draw 8 AND gates, and the output that comes out of each AND gates will be either 0 or 1. So if we take a particular example, a particular combination, it will be 1, and we're going to make it 1 by just using the circuit diagram. So first thing you will have to do is make an enable signal and supply it to each of these AND gates. You can see that I have supplied it to each of these NAND gates in this portion. So you can see the 4th output of each of these NAND gates is connected to this line. If you can see this line, it is the line that points to the enable signal. So this is how you will supply it to the AND gate. Now you can see the rest of the 3 inputs, the rest of the 3 wires you can see here are basically representing the information that comes out of this AND gate. So let's pick up any particular case and we will see how this circuit diagram is doing the job for us. So let's take a particular case of 0 1 1. So 0 1 1 means that the value of A0 will be 0, the value of A1 will be 1, and A2 will be 1. So what I've just done here is I have just created 3 connections out of all these 3 inputs, and if we take this particular case of 0 1 1, you can see that the 3rd input is actually 0. So first initially we will supply 111 to all of these values, and then we are going to invert these values whenever we want to write 0 in any particular position. So you can see that here 0 1 1 represents A0 should be equal to 0, A1 should be equal to 1, and A2 will be equal to 1. So since we are supplying 1 to all of these inputs, we know that the value of A1 and A2 will be same. So we do not need to use this inverter gate. You can see that this one is an inverter gate. But in case of A0 signal, we will have to use this inverter gate. So the rest of the 3 inputs that we are going to provide to this AND gate, 2 of them will be directly connected to this connection. So you can see that A1 and A2 are 1. So this connection represents A2, this represents A1, and so you can see that this basically connects directly to our AND gate, which corresponds to this case. And similarly you can also see that A2 is also connecting to this gate. But if you see that example of A0, it is 0. So we will have to pass this signal through this inverter gate, and after passing it to the inverter gate, you can see that now it has become 0 here. So although this looks a complex circuit diagram, but this is how actually it works. The very basic idea is just to invert the gate, use the inverter gate whenever there is a 0 in the output. And since the AND gate will give you a 0 or 1, it will be 1 in this case whenever you want to specify a particular combination. So this is the circuit diagram, and you can actually get this circuit diagram anywhere on the internet, and I've just explained a simple case, and this applies to all of these cases. So if we pick up another case which is 111, so if the information is 111, we are not going to use an inverter gate because all of them are 1. So we are directly going to supply these values from this direct connection. But whenever we take a 0, so let's take this example, this case 000, all of them are 0. So we are going to connect all the 3 inputs of this AND gate to the inverter gates of all of these 3 input signals. So that's a remarkable point here. So that's how a decoder works. That's how a decoder basically decodes or converts the binary information from encoded inputs to a maximum of 2 raised to the power n outputs. So if you have understood the concept, if you have any doubts, you can ask it in the comments below, and make sure to like this video if you have liked this video, and subscribe to our channel so that you will get notified at each and every time we upload a new educational video. And you can even get our Android application to get access to all of our content, and you can see more videos which will appear on the screen here. So thanks for watching and supporting us.